NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
Scientists looking for life on other planets like to talk about the Goldilocks zone, not too hot, not too cold, but just right. And now NASA's found a planet that's right in that zone.
Astronomers have made a groundbreaking discovery on the perpetually dark side of Proxima Centauri B, a side that has never been touched by the light of its star. Long assumed to be a cold, barren wasteland, this shadowy region is now revealing something unexpected. Emerging from the darkness are faint but distinct emissions, signals that defy our previous understanding. These emissions, originating from Proxima Centauri B's dark side, have a unique character. They might include artificial light, heat radiation, or other forms of electromagnetic radiation, such as infrared. Unlike natural starlight, their distinct signature suggests they could be the product of an advanced system or technology. Thanks to the James Webb Space Telescope, JWST, which excels at detecting faint infrared radiation, scientists are able to observe these signals more clearly. What if these emissions aren't merely lights, but clues to something far more profound? Could they point to the existence of a hidden civilization or uncover a mystery beyond anything we've imagined? The implications for potential inhabitants are profound. How might emissions from the dark side of Proxima Centauri B help us uncover details about its possible residents? These faint emissions could represent more than just energy use. They might hold the key to understanding life on the planet. If the emissions are artificial, they could point to a technologically advanced civilization. The patterns of light and heat might reveal the type of technology being used, the scale of energy production, and even offer clues about the planet's social structures. Consider how Earth's city lights tell stories of our political boundaries and social dynamics. Brightly illuminated cities often reflect economic power and political focus, while dim areas might indicate poverty or limited infrastructure. In a similar way, emissions from Proxima Centauri B could provide insights into the values and priorities of an alien civilization through their energy usage. What secrets could the dark side of Proxima Centauri B hold? Could it reveal more than just artificial lights, perhaps an alien society in motion, showcasing their governance, technological progress, or even their challenges? These faint signals might be our first glimpse into a completely different way of life, light years away. Tidal locking significantly influences the conditions on Proxima Centauri B. Because the planet is tidally locked, one side is perpetually facing its star, while the other side remains in continuous darkness. Unlike Earth's night cycle, the dark side of Proxima Centauri B never experiences sunlight, leaving it in permanent shadow. This constant darkness results in extreme cold, making the dark side uninhabitable without an external source of heat or light. In such an environment, artificial lighting would likely be crucial for supporting any form of life. On the dark side, these lights would not only provide warmth, but also serve as a source of illumination, potentially making the area habitable. Without such artificial energy sources, the dark side would remain too cold and dark to sustain life as we understand it. The consistent nature of tidal locking creates a predictable environment on the dark side, meaning emissions from this region would likely be steady and regular. Astronomers could detect these artificial emissions, offering insights into the amount of energy used to sustain life on that side of the planet. Advanced telescopes, such as the James Webb Space Telescope, JWST, and the proposed LIR, are specifically designed to detect faint emission signals that might indicate extraterrestrial life. These cutting-edge instruments are capable of capturing narrow bands of light, especially in the infrared spectrum, which is crucial for identifying artificial emissions. Unlike the natural starlight that dominates our view of distant stars, these faint signals could stand out as something entirely unique, allowing astronomers to identify a thrilling possibility: artificial light. The James Webb Space Telescope, JWST, excels at honing in on specific wavelengths of light, particularly those emitted by artificial sources. Its infrared sensitivity enables it to detect heat radiating from a planet, even across light-years of distance. This capability is key because artificial lights potentially illuminating the dark side of Proxima Centauri B might emit heat that is detectable through JWST's infrared lens. By studying these wavelengths, astronomers can distinguish between natural starlight and the distinct signature of artificial light. Detecting such faint emissions could revolutionize our search for extraterrestrial life, paving the way for unprecedented discoveries. We are not just on the brink of identifying new planets, but may also uncover signs of intelligent civilizations. With the advanced technology of JWST and LIR, we might recognize a civilization on a distant world, simply by observing a light pattern unlike anything we've encountered before. But there's more to consider. What kind of technology might be needed to create artificial lights on Proxima Centauri B? The implications of such a discovery extend far beyond detecting emissions. It could reveal technologies that enable life to thrive in an otherwise uninhabitable environment, effectively transforming the dark side of Proxima Centauri B into a livable space. Advanced extraterrestrial civilizations would likely rely on cutting-edge technologies to generate both light and heat. One possibility involves photovoltaic panels, solar cells capable of converting sunlight into electricity. Although the planet's dark side doesn't receive direct sunlight, these panels could be installed on the perpetually sunlit side, capturing solar energy and storing it for use in shadowed areas. Alternatively, they might employ other advanced energy sources, such as nuclear fusion reactors, which can produce immense power without depending on sunlight, or even artificial photosynthesis, a process mimicking how plants convert light into energy. These artificial lights would serve two vital purposes, providing illumination and warming the dark side to sustain habitability. Much like Earth depends on electricity for lighting and heating, the inhabitants of Proxima Centauri B might rely on sophisticated systems not only to brighten their environment, but also to maintain livable temperatures in the planet's constant shadow. Could these artificial lights signify something far greater? Perhaps the presence of an advanced technological society? These lights might not merely serve as a survival mechanism, but could indicate a civilization with extraordinary energy management, engineering prowess, and the ability to manipulate their environment on an unimaginable scale. Their very existence might suggest that the inhabitants of Proxima Centauri B have developed technologies that, to us, would seem like the realm of science fiction. While emissions from the dark side of Proxima Centauri B have been observed, understanding or analyzing them poses significant challenges. The immense distance between Earth and Proxima Centauri B makes isolating the faint signals from such a distant world extremely difficult. Moreover, even the emissions we've detected are so faint that distinguishing them from background noise remains a considerable obstacle. Proxima Centauri's solar flares and cosmic radiation add complexity to our efforts, potentially disrupting the clarity of the signals we're attempting to study. However, progress in telescope technology is expanding the possibilities. Instruments such as the James Webb Space Telescope (JWST) and upcoming telescopes like LIR are specifically designed to focus on certain wavelengths of light, including infrared emissions that may come from Proxima Centauri B. These advanced instruments are highly sensitive, enabling astronomers to isolate these emissions with greater precision, despite the vast distance and interference from cosmic phenomena. Could Proxima Centauri B's natural emissions lead scientists to mistakenly classify the planet as a lifeless rock? Even with breakthroughs in emission detection, what we've discovered so far may only be the beginning. Thanks to further technological advancements, the true story might still be concealed beneath a veil of cosmic noise. Although emissions have been detected from the dark side of Proxima Centauri B, some of these signals could very well be natural occurrences rather than artificial lights. Earth offers similar examples of such emissions, like the shimmering auroras that result from the interaction between solar wind and our magnetic field. Proxima Centauri B's volcanic activity or atmospheric phenomena, such as auroras, might create comparable glowing emissions. Given the planet's unique position, with one side perpetually facing its star, it could experience significant volcanic or geothermal activity, releasing heat and energy into its atmosphere. This complexity may make it especially challenging to differentiate between artificial light and natural emissions. Much like the auroras on Earth, which can sometimes appear vibrant and otherworldly, volcanic lightning or intense storms on Proxima Centauri B could produce emissions that might be mistaken for the glow of a city. These emissions, faint and erratic, could obscure our understanding of what's happening on the planet's dark side. Could Proxima Centauri B be hiding something beneath its surface? What if these emissions aren't signs of a city but instead point to a planet full of volcanic activity? The true nature of what's beneath the surface may be far more intricate than we realize, hinting that the dark side of Proxima Centauri B might not just contain a few lights. It could conceal a dynamic, constantly changing environment. Proxima Centauri B's atmosphere could have a significant impact on the emissions observed from its dark side. If the planet possesses an atmosphere, it might function as a filter, altering or absorbing certain wavelengths of light before they reach our telescopes. This means that even if artificial lights are shining brightly on the dark side, the atmosphere could absorb or scatter some of that light, making detection more challenging. The composition of the atmosphere, whether it's rich in gases like carbon dioxide, nitrogen, or more exotic compounds, could influence how light behaves as it travels through it. For example, some gases absorb specific wavelengths, which would modify the light's spectral signature by the time it reaches our instruments. This means that while we might detect emissions from the dark side, we may not fully comprehend their true nature without accounting for how the atmosphere impacts them. What if Proxima Centauri B's atmosphere holds the key to unlocking the history of its emissions? The way it filters these emissions could offer valuable insights into the planet's past, its development, environmental changes, and whether it could support life. By harnessing the capabilities of cutting-edge telescopes like JWST and LIR, we are on the verge of making groundbreaking discoveries. These instruments have the potential to detect faint emissions from the dark side of Proxima Centauri B, possibly revealing signs of life or advanced technology on a distant world. With these advancements, we will not only address key questions about the planet's habitability, but also open up new possibilities in the search for extraterrestrial life. The future of space exploration is filled with promise, and each new breakthrough brings us closer to understanding if we are truly alone in the universe. These discoveries have the power to revolutionize our understanding of the cosmos, and we are poised on the brink of something extraordinary.